So, uh, very good afternoon to you. My name is Kim Morgan. I'm the Outreach and Communications Coordinator here at UCL Biochemical Engineering. It's great to have you with us this afternoon. Thank you very much for joining this webinar, which is what can I do with a degree from biochemical engineering? So, just to let you know how this session's going to run. It's being recorded, so everybody who registered will be sent a link afterwards so that they can watch back. So if you miss any part of this, you will get sent a link to a recording. We'll send out a link to YouTube. We'll also send a link out to a Zoom recording. So if you're a part of the world where you can't view YouTube, you should be able to watch the YouTube link as well. Okay. Once we get going, if you have any technical problems, if you can't hear us, or any kind of problem with the video, you can use the chat function there to let us know. Now, what I'm going to do is I'm going to set a few poll questions going because we'd really like to know some things. So there are a few questions in the poll, and it's asked, first of all, you don't have to answer this. It's purely for our information. We're just curious. We'd just like to know. How you found out about this webinar, maybe you found out through UCL email, or you saw it on the website, or do you have an offer to study from us? And finally, where are you joining from today? We're just curious where in the world you are. So let's have a look. Great, I can see some people are filling that in. Thank you very much for joining. Thank you very much for that. So this is really helpful because they can immediately see that from the look of this, most people don't have an offer to study with us. This helps us because we know that if you have an offer to study with us, you've already obviously put in an application, so we know at what point in the cycle you are. So this is great. And we'll go back and look at how you found out about this webinar and where you joined from. So I can see, yeah, really good response rate there. Thank you very much. We appreciate that. I'll leave it up on screen so you can fill it in later. So just to let you know how this session is going to run, I'm going to hand over to my colleague, Dr. Jack Jeffries, who's the admissions tutor here at UCL Biochemical Engineering. He's going to give you a presentation on what you can do with a degree from biochemical engineering. You can put a question at any point in the session. If you look at if you're joining a mobile device, you may not have seen the buttons, but you've got a series of buttons at the bottom. You can choose how you want to configure the screen, but you've also got a Q&A function. So please post your question in the Q&A. It's really helpful for us because we can see your questions as they come up, and it's much easier to manage than if you put them in the chat. If you put them in the chat, we might miss them. So just to make sure we get to them, put them in the Q&A box. We'll wait until the end of the session before we answer them, because I know a couple of people have actually already submitted questions by the form that I sent around, but you can post them at any point as we go along. I'm also going to put my email address in the chat, so if you have anything that you'd like to ask afterwards, or there's anything else you want to follow up on, you can always get in touch with me directly afterwards. So thank you for your patience as I explain everything. I'm going to hand over to Jack now.
Great, thank you, Kim, and thank you everybody for joining us today. Very welcome. As Kim said, my name's Dr. Jack Jeffries. I'm a lecturer in the department, and I'm also the admissions tutor. So I'm going to talk to you today a little bit about what biochemical engineering is, what we do at the department, what we can teach you, the courses we have, and I'm going to tell you that so that makes sense then moving on to sort of what sort of careers those courses open up to you, what biochemical engineering can open up for you, and also some data about where our graduates go on after they've finished with us. So I'm going to go right ahead and jump into that. Let's see if we can get this thing to work. Which it won't do. Technical issues. There we go. Yeah, what is biochemical engineering? And it's a good question, and we're kind of one of the only dedicated faculties in the UK to teach biochemical engineering. And in fact, we were the first, and we came out of chemical engineering at UCL. And in the 1950s and 1960s, a group of academics wanted to create a course which was particularly about biochemical engineering, moving from the learnings and the understandings of chemical engineering, but applying those to a biological space. And that's kind of how we've continued till today. I'm going to try and click onto the next slide. Sorry, the computer's been a bit unresponsive. There we go. So biochemical engineering is a really interdisciplinary subject, and it sits at that interface between chemical engineering and biotechnology. So it brings in all of those learnings of chemical engineering, which kind of came out of the chemicals revolution and the industrialization of the chemicals processes and the fossil fuel industry. How do you mix components at scale? How do you filter them? How do you distill them? How do you purify them? How do you take these products, mass produce them, okay, in large reactors? How do you control the temperature? How do you control the oxygen? How do you control all those elements in a big reactor vessel? And how do you bring those products to scale? It takes in all of the key learnings that came out of the biological revolution, sort of the DNA revolution out of the 50s, the discovery and the understanding of DNA, Watson and Crick, all of the sort of the biotechnological aspects of that, the sequencing revolution, how do we manipulate and use these DNA elements to make things, and understandings about life processes, how cells grow, divide, make products, make small molecules, and it brings those two together. So you have all of those chemical engineering principles, thermodynamics, fluid flow, mass transfer, mixing, and you put on top of that the complexity of biological life. Yeah, all of the stuff that we know about biological life to date, and lots of the things that we don't know, and lots of biological processes are still being understood and researched and developed, and all that information feeds back in. And biochemical engineering sits then at the interface of those two disciplines, and it translates the learnings of biology, applies the chemical engineering techniques and tools, and takes them through to produce products, medicines, chemicals at scale for distribution to end users, either through medical systems or commercial industries. So let's just, I just want to see if yeah, okay, I got the right slide. So let me just talk a little bit about the courses that we offer here at UCL. So I've given a bit of an overview of what biochemical engineering is. What sort of streams do we offer here at UCL? So we have two streams or three. The B-Eng and the M-Eng stream. So that's the biochemical engineering stream, or the Masters in Biochemical Engineering stream, and that's a 3-year course if you take the B-Eng, or a 4-year course if you take the M-Eng. The modules are the same all the way up to the 3rd year, and then if you stay for the Masters course, there's an extra year on the top. I talk about that a little bit more later. And we also have a BSc stream. So, and that's in the bioprocessing and commercialization of new medicines, business and management. And what that does is teaches you a lot of the core biological processes, a bit of the biochemical engineering, but has a focus on the commercial aspects of the biochemical engineering industry. So how do these new medicines be developed, how they taken to scale, how they commercialized, how they advertised, how these businesses built and run. Okay, so it's a much more of a focus on that management and business side. But of course, we feel that to understand how that industry runs, it really helps to have a core underpinning of a knowledge in the scientific and the practical areas that it works in. And as I mentioned before, biochemical engineering department at UCL was pioneered. It was one of the first biochemical engineering programs, and our graduates, we like to think, and we know, are in demand by the biotechnology industry worldwide. So that's just the degree courses that we offer. And just going back to that 4th year, that M-Eng year. So the B-Eng has 3 years, and then you finish with the bachelor's. The master's equivalent of that has a 4th year, and that 4th year you can choose. So you could do a master's in biochemical engineering, you could stay with us and do some research. You could go to chemical engineering, our sister department, and do a master's there. You can do an M-Eng in business and management. So you can, if you're interested in the business and commercialization side, even though you're on the B-Eng and M-Eng streams, you can sort of specialize in that. We take place, we participate in the study abroad. So you can go to an institution outside of the UK that participates in that study abroad program that we have an agreement with, and do a master's year there. And what's really popular is that we have a master's of a year in industry. So we have a lot of industry partners, and what that means is you'll go to the industry and you'll do a project based at the industrial partner. You'll work in their labs or in the business in the industry with them for the year, and that's really popular. So that's sort of how the MEng works. And just one thing to mention about the BEng and the MEng, which is important for careers, is that they're accredited degrees. So they are accredited by the Institute of Chemical Engineers. And what that means is that if you take the BEng and the MEng stream, it's your first step on your route, on your path to chartership, becoming a chartered engineer. And what you need is a degree in a chartered, an accredited program like we offer. And then after you leave, you'd need 4 to 5 years of industry experience. And once you have that, then you can apply to become a chartered engineer, but you can't do that without having both of those aspects. So you need to take part on a accredited degree, and our BEng and MEng are accredited degrees, and we've had our reaccreditation process last year, which we passed, so we can still offer that accreditation. And there's just a little graphic down here to show that if you are a chartered engineer versus a non-chartered engineer, your salary, you command a higher salary across your working life. Yeah, so it's a really important thing to get, and it helps you demand a higher salary and better income when you go on to work within the industry. Okay, so that's really something we're very proud of. Those are BEng and MEng degrees. So I've talked about biochemical engineering as a discipline. I've talked about the different courses we have, but what does that mean in practice? What does that mean in the real world? How would you have come across a product that a biochemical engineer would have made or been in the process? And the answer to that is most likely yes. If any of you have ever had a vaccine, if you've ever taken any pain relief, if you've ever had antibiotic, okay, all of those things come from biological systems. They would have had a biochemical engineer working through that pathway, either in discovery or optimization or scale up or rollout. Okay, all of those things fall under biochemical engineering. What else? And here's an interesting one. Anything which has a fermentative process. So if you've ever had any yogurt or alcohol or vinegar, all of these things are fermentative processes. They use biological systems, yeasts or other bacteria, and they're done at scale. So you've got to know how to grow and feed and keep alive these organisms at scale, and then separate them from their downstream products if you need to. All of that brings in the fundamental underpinnings of biochemical engineering. So you probably hadn't thought about it in that way, but even the food that you eat, the medicines that you take, the vaccines that you have, even some of the materials that you use will have come out and been developed and worked on by biochemical engineering. And that's sort of the work that we do at biochemical engineering, because we're a teaching department, but we're also a research department as well. So we have research academics who teach on the course in the areas of vaccines, antibiotics, immunotherapies, bio-based alternatives to petrochemicals, okay, industrial value adds, a more sustainable future through biochemical engineering, regenerative medicines, and what should be here also is a really new big strand in the department, which is about lab-grown meat, okay, and that comes under sort of regenerative medicines and cell therapies, okay, and then also what's cross-cutting between those are sort of the tools and the techniques of what might have been called genetic engineering in the past, synthetic biology, or engineering biology is the new buzzword that we have in the UK for it. But all of those tools and techniques, the ways of thinking about how to use these systems, develop them and optimize them, they cut across all of those research strands. And that's what we do and teach in the department. And that gives you a really good skill set and a basis to go off into those different disciplines. So if you're interested in vaccine production or medicine production, and we can teach that, you'll learn that, and you can go into work into one of the companies that delivers Oxford Biomedica, GSK, Pfizer, AstraZeneca. If you're thinking about industrial biofuel production, it's not such a big industry in the UK, but on the continent, places like BASF and a lot of the big chemical companies, Unilever, Procter & Gamble, they all have a big desire and a need to move to more sustainable production, and that's a big focus for them. And biochemical engineering is one way to deliver on those goals, to be more sustainable, get away from fossil fuels. Okay, so that's the sort of, you can see now how the learnings you get on these courses can lead you into those different fields and those different industries. I don't want to spend too long on these slides. I think I've talked enough about biochemical engineering, but it's just to know that biochemical engineers work across the whole of that value chain. So right from the small scale, early research at the lab bench, all the way up to sort of manufacturing scale, greater than 1,000 liters, the downstream processing, even things like quality assurance and packaging. Yeah, it's all very well and good to make your product, but if you can't package it with a long shelf life and get it to where it needs to go, it's no good. Okay, that's a big part of it as well. So biochemical engineers really go across that whole value chain. And when we talk about value chain, if we focus on sort of medicine production, that's a really expensive and a really high cost value chain. There's just a description of a clinical trial, sort of a therapeutic, an API from research to market here. It can take, up to 10 years, hundreds to billions of dollars, and you can get all the way to clinical trials, phase 3, and the product will just fall over, won't get to market. So there's a huge amount of money and pressure involved in that. And so, we like to say of our students that we're teaching them to have nerves of steel and cool heads, because you're going to be responsible for dealing with that sort of huge amount of money input, dollar input, and the risks that come along with that as well. Okay. And having talked about all of those different things, these are just a sort of a description of all the different skill sets that brings in: physics, mathematics, chemistry, thermodynamics, heat, mass transfer, fluid flow. Okay, the biological aspects, absolutely, living systems, engineering, designing of reactors, designing of plants, biochemistry, the underpinning of life, the fundamental chemical reactions, medicine, how does that apply in a human context, and business, because as we know, a lot of these products are mediated with the public through the market, through big industrial companies. And that's how these products will get to their market. So it's an understanding of cost chains, life cycle analysis, techno-economic analysis as well. Because we teach you all that, because we teach you all of the biological and the chemical engineering underpinning, the ability to analyze and process data as well, a rational approach to data analytics and understanding. All of those skill sets come together and make our graduates very sought after by a range of sectors. So biotech, obviously, stem cell and pharmaceutical companies, absolutely. Because of the chemical engineering that is embedded in it, you could move into the sort of more traditional petroleum and chemical industries as well, industrial biotech. A really big one for our students, as you'll see in a few slides, is the finance sector, management consultancy. Of course, because we're teaching you to process and analyze numbers, there's a high level of on the B Eng and the M Eng and in the business and management as well. So there's an analytical mindset that we're training you with, which plays a big role in finance and the banking industry. Lots of people move into related but different sectors. So patent law or scientific journalism, although that's much more common perhaps at the postgraduate level. And of course, lots of our students go on to pursue research. They get a real love and a feel and a desire to want to continue that research. They love being at the lab bench. They love discovering new things, putting things into place. And lots of our students go on to do research either with us or at other institutions. So I just brought up a bit of data here. So this data set comes from the graduating class of 2021, 15 months after they graduated. So that would have been 22, just the sort of the back end of 2022, maybe the start of 2023. So it's about last year. Okay, and there's a new data set which hasn't come through yet. And this is just a description of sort of where they've ended up and the average sort of salary. So 60 to 70% of our graduates end up in highly skilled work. Okay, another 14% going to postgraduate study, 5% going to other work. Some are unemployed, others are look in at sort of either travel or they're caring, or they're going to sort of voluntary or charity work. But we've got a really high percentage of people who go to positive destinations. So about 95 of our graduates are happy where they've ended up. And you can see there that the average salary is about 38 to 39,000, with the median at about 32. So that's the most recent cohort that we have data for, which is really good. Lots of our graduates go on to very successful roles after that, and they command a high salary as well. So that's undergraduate leavers. That doesn't bring in postgraduates. So I filtered it for undergraduates specifically. What sort of industries do they go into? Well, this data set is actually for all of the responses that we've had from 2017. So this brings in all graduates from 2017 to 21, and it will be where they are 15 months after they left us. So you can see lots of the graduates end up in manufacturing. So obviously lots of people coming through with the B-Eng, the M-Eng, they go into process roles, they're working at companies, working in biochemical engineering, perhaps pursuing that path to chartership. Yeah, getting that experience. Lots of people you can see going to accountancy and financial services, coming back to that analytical mindset I talked about teaching. Lots of people go on to do scientific research, IT and technology, consultancy, policy and government, academic research, energy, natural resource, health and social care. Some go on to law. So there's a whole range of different things that they can go on to, with a focus perhaps on following sort of that route into manufacture or engineering processes, but of course, as I said, finance and IT and sort of the business and management side as well. And if we're looking at those who are in full-time work or employed or self-employed, about 95 of them work for an employer. About 4 to 5% have gone on to further study, master's or a PhD. And then there's a percentage, 2% of people who go on to start their own business as well, which is really great. And that's something that we encourage, and is also lots of people have gone on to do. So I just want to talk about, I'm sorry, I'm just skipping through. Okay. I just want to talk about prospects for the coming years. Okay. So that's what's gone. Those are where our graduates have gone so far, and they've gone on to sort of high-paying jobs across. I wonder if I have the names of the companies. I do a bit later of where they've gone on to, so I'll come back to that. But there's a quasi sort of private non-profit organization called the Catapult, and it specifically focuses on cell and gene therapy. And they do a survey of the industry, and that's where a lot of our graduates go into. That's a lot of industry in the UK is focused around sort of health and stem cell and what they call advanced therapeutics these days. And what they found is that every time they do their survey, they have a projection of total jobs. And then when they come back after a few years and they compare actual jobs created in the industry to predicted, what they see is the actual job creation always outstrips the predicted. So we can see from the 2019, the prediction for bioprocessing jobs and total jobs in the sector was about 2,000. And then if you look it for actual here over 2021, you can see actually in bioprocessing that was up at 4,000, total jobs up at about 7,000. So demand outstrips the predicted supply of graduates as well. So what I'm trying to say is that in this sector in particular, and more widely across the biosector, there's a huge skill shortage, and that's well known and been seen across all of our industrial sponsors. And that's not just in the research and development and discovery, but you can see in the manufacturing side, and lots of our graduates go into manufacturing, but also supply chain and logistics, process development, quality control, commercial. Okay, so you can see how graduates from the B-Eng and the M-Eng, with their sort of more theoretical background, the engineering background, can move into jobs in process development and manufacturing, but also graduates from our BSc management stream will find jobs in the sector as well, because as those businesses grow, they need people who have understanding of the regulatory systems, have an understanding of how to commercialize these new therapeutics coming through. So really, it's a great time to be learning and working in this sector. And there's a huge skills demand in the UK in this sector in particular. And here's just some of the places that our graduates have gone to after they've left us. So from the BSc degree, you can see that people go on to work perhaps more in management and business side, so management consultancy, business analysts, or they might move into policy, industrial relations officer, or working in finance. We've got people who've gone to Bank of America, Merrill Lynch, but also they've gone on to do further studies. So they'll go on to do MScs, maybe in international health management or some other MSc aligned with that degree. From the BEng and the MEng degrees, you can see lots of people go into the same sort of places, management consultancy, business analysts, yes, but also they go on to be engineers, process and production engineers, following that path to chartership, okay? Or they'll go on to do further studies, and lots of people go on to do that MSc year, they'll go on to do EngDs or PhDs in biochemical engineering, either with us or other institutions, or they'll move into the industrial companies like GSK and Eli Lilly, okay? And that is very sort of, that route's a bit more well-trodden from the BEng to the MEng degree, because if you remember with that MEng degree, we have the year in industry. Obviously, that's with an industrial sponsor. It's quite common that people who get onto that MEng year in industry scheme find the transition into their parent company or that company somewhat easier, okay, because they're already familiar with the company knows them, they've been working on a project with the company. That kind of opens up doors to them to move into that company. So that's quite a common path treaded through that way. I'm just keeping an eye on the time. I don't want to go too long. I want to give enough time for questions, okay? So I just want to talk about, we've talked in general and we've had some statistics. I want to just pick out some highlights of the alumni who've come out of the department. So our alumni, as I said, go on to work at a whole range of companies. And this is kind of a list of companies that we have links with, that have sponsored year in industry projects that our students have gone on to work with. And you can see big names there, AstraZeneca, of course, British BP, so, you know, the chemicals and the fossil fuels industry. Yes, absolutely. GSK, KPMG, thinking about more finance or consultancy. PAL Europe, which is now, or Paul, which has now become Cytiva, Pfizer, Shell, Unilever, these big names that I'm sure that you've heard of, okay? And they'll go on to work in those companies either as process and development engineers at the lab bench, they might move into consultancy, they might be more on the management side. There's lots of different routes into these companies through the different degrees, okay? So here's a big hitter, Professor Barry Buckland. So he had a PhD, got a PhD with us in 1974, and he went on to work for Merck, which I'm sure some of you will have heard of. It's a big pharmaceutical company. And he joined them in 1980, and he built sort of their bioprocess R&D group from the ground up. And he was the leader of that group and brought to clinical trials and brought to market a huge number of drugs, which are all listed here. So he's a really famous and like quite, you know, a great example of an alumnus from UCL Biochemical Engineering. When we looked at that profile of where people went, a lot of people went into employment with big companies. Some went on to study, but also what we had was a section of our graduates who became sort of self-employed. So they started up their own companies, and the biochemical engineering department has quite a good track record of spinning out or spinning up companies. Usually that happens at the postgraduate level, but it's not unheard of it to happen at the undergraduate level. And that's definitely something that can happen. I've just got a few examples from the recent history of students or colleagues who've gone on to start their own companies. So Purify was a sort of a company started by a PhD student in about 2013. It was a new technology for purification columns. They were bought out by GE Healthcare, which is now Cytiva Healthcare. The names always change, and that still maintains as an operating unit within GE Healthcare. Okay, that's on the market now. Dr. Kay Miller span out a company called Axitan, and they had a focus around using algae for delivering therapeutics to in agriculture. So you can see that the different, it's not all the same sort of technology, it's across the breadth of the things that we research. Here's an interesting one. Nat Sai was with us. She was actually a student, an art student at Central St. Martin's, but what she was doing, she was using a bacteria, Streptomyces, which produced a pigment, sort of a blue-purple pigment, and she was using that to stain fabrics. And she started up a company called Faber Futures, and they produce sort of high-fashion clothing which has been dyed using the product of a bacteria. Okay, and that was really interesting project. I knew Nat Sai. I was in the same lab as her when I was doing my PhD. So it's not that brings in biochemical engineering, but of course, it's everything today is so very interdisciplinary. So we can bring in lots of different people. And then most recently, a colleague of mine, another colleague, James Allen, started up Twig. They're a new biotech company, and they're trying to put in place solutions for a whole host of different biochemical engineering problems. So we've got a really great track record of spinning out and spinning up new companies as well. I think that's Kim's jumping on, and that's really great timing because this is actually the end of the slideshow. So good timing by everybody. But if you have any more queries, you can, of course, always email me or Kim, but you can also get in contact with our senior teaching fellow and careers liaison officer, Dr. Mike Sulu, and his address is there on the slide as well. And I'm going to leave it with that slide, and I'm going to say thank you very much for your attention. Hopefully I didn't go on too long. Let's see the time. No, pretty much perfect, half an hour. Polished now. So Kim, what's the best thing? Should we move to Q&A or?
Yeah, absolutely. Well, if you want to have a look at the questions, because we've had some questions throughout the course of the talk. I mean, there's some really good ones there. Ones which do come up quite often in these sessions. So it's really, yeah. There's some very relevant questions. But yeah, also there's one that somebody sent in advance, which is in the chat. So whilst you have a look through those, I just want to plug something else we've got coming up. We do a series of webinars called Spring into STEM, and we've got 5 coming up this year. We'll be covering biodegradability and the impact of plastics on microbiomes, and that's one from Jack's team.
Yes, it is. So please, I'm plugging that one as well. Thank you, Kim.
Absolutely. We're also doing one on stem cell and gene therapies, which is one we often do because it's a really exciting area that we're working in. We even do an MSc on that one. We're doing vaccine manufacture. Again, it's a core part of what we do. We're also doing lab grown foods. And that's in April. But the final one that we're doing is innovations in autoimmunity, so diagnostics and treatment. So we've got a research fellow working with us who's actually working on things like lupus, so autoimmune diseases. And I think it's a really great way of illustrating how someone becomes a biochemical engineer because of what they're doing. And that happens a lot throughout engineering. People from different disciplines join a team to solve a problem and become engineers. So that's Dr. Thomas McDonnell who'll be presenting that talk. But they're all really, really representative of what we do. Very exciting, and I hope you'll sign up to them. So when I send you the email afterwards with a link to the recording, I'll include a link to each of those Spring into STEM webinars, and it'd be great if you could join us. It's a chance to really dig deep into some subjects. So Jack, I'm going to hand over to you, whichever question you'd like to start off with.
Absolutely. Shall I start from the top? So it's got a question here about biochemical engineering at UCL. In general, in the 4th year, so it's talking about sort of that year in industry. You have an array of options you can do. So it's asking, can you specialize in chemical engineering and so do biochemical chem engineering? So the year in industry with us you'd have to do it in biochemical engineering because the industries have links and set projects up with our department. So someone like Eli Lilly or JSK, they'd have a project which they come to our lead, our program manager, and say, we'd like to put this in the pool. Can we do that? So you'd have to stay with biochemical engineering to do that. It may be that chemical engineering have a similar program and they have industrial companies who come to them, but I don't think you'd be able to access their industrial year in industry program because you'd be a biochemical engineering student. You could, however, do a master's in chemical engineering, which would be at chemical engineering, but that would be more of a taught program, perhaps with a research element to it, but it wouldn't be their year in industry. Okay, so I hope that makes sense.
And also,
I think, yeah.
I just want to clarify that if you choose year in industry or study abroad, these are competitive things. So whilst they're offered, it depends on availability, and it's a competitive process to get them. So just to make it clear on that front when we talk about these programs.
Yeah, absolutely, and that's done then by attainment. So it's done to the students who are attaining. the highest. Okay, and then okay, so that's good. But actually, that kind of really helps with the next question. So, is there a difference between the opportunities available to Chem Eng graduates and Biochem Eng graduates? So I think chemical engineering is much more about sort of the traditional chemical engineering industries, a lot of which, as I said, came out of the fossil fuel industries. There are overlaps, of course. So I'm talking about the modules on thermodynamics, fluid flow, mass transfer. Those are all key. If you were to do biochemical engineering, you probably would have more of opportunities in industries which are related to bio-based. But if it was something that you wanted to do into chemical engineering, then maybe what would be good is that you actually then do that master's year in chemical engineering. So what you do then is get the top up effectively of those chemical engineering processes. Okay, it's all accredited by Institute of Chemical Engineering, but you have then specialized in your fourth year to be more about more traditional chemical engineering, and that may then open routes into, as you said in the question, oil and gas sort of based companies. Yeah, so absolutely, it's all accredited by the Institute of Chemical Engineers. We have to match their profile, and their profile is really kind of more tailored for chemical engineering. There are a lot of overlap between the different disciplines, but I think that route probably would make a lot more sense if you wanted to move more into the oil and gas industries. Yeah, perfect. So hopefully that answers that question. How much biology is in the course? Okay, you're applying for biochemistry. Excellent, but I'm also interested in maths. So I'm wondering if the course has a balance of those two. So there are, every year there's modules in, but it's sort of molecular biology, biochemistry, applied. So, and those are the modules I teach because I'm a biochemist by training, by background. So that's really, it gives you the knowledge you need to know about biochemistry, the small molecules that make up the cell, how they interplay, different systems within the cell, but with a focus on giving you enough understanding so that you can use them, engineer them, or take account of them in your engineered systems. Okay, so it's balanced like that. And then on the other side, for the maths, for the B-Eng and the M-Eng, that's a requirement to have maths to come onto those streams, because you'll be doing things like thermodynamics and fluid flow and mass transfer and statistics. Yeah, so there's a requirement for a level of mathematics that we ask students to come in with A-level maths or an equivalent. Okay, and those two are sort of balanced out, but there's a bit more on the engineering side than there is on the biological side. So hopefully that answers the question. You get the basics and the underpinnings, you get what you need to know to apply, but it's not a biochemistry degree, so you won't get it to the level of detail that you would have in a biochemistry degree, effectively. So hopefully that's answered that one. Is there a possibility to do a Bachelor of Biochemical Engineering and then do a Master of Biotechnology and vice versa? I don't know if I'm not. So I'm sorry, I can't comment on provision of other degrees at UCL or actually elsewhere. But I think what your question is saying is, if you do the Bachelor of Biochemical Engineering, could I then go on to do a Master's of Biotechnology somewhere else, potentially, or at UCL if there was one? And absolutely, I think so long as you match the requirements sort of attainment-wise, then you could go on to biotechnology. What I say a lot to my tutees is that if you know that there's a master's course that you're interested in, say it's in biotechnology, or let's say it's in stem cell and gene therapy, I didn't go into too much detail on the way the course is structured. I think there's a video online where I do that. So if you're interested in that, you can do that. We also have online open days and in-person open days, and I can discuss it a bit more there. But on the different courses, you have different levels of being able to choose optional modules. So what I say to my tutees is, if you're really interested in stem cell and gene therapy and there's a master's out there which you think you'd like to do, pick the stem cell and gene therapy minor modules. Tailor your learning to where you think your outcome will be, where you want to go. Okay, and we give the ability to, within reason, and it's different for the B-Eng, the M-Eng, and the BSc, to tailor your learning to suit where your career path, your learning path going on forward. So I think biochemical engineering would give you enough of the basics, and with those minor options that you have, to allow you to do that master's in biotechnology, whether that would be at UCL or elsewhere. Okay, so hopefully that's answered that one.
And just to let you know that there was recently a webinar with Dr. Petra Hanger where we talked about the MSc Biochemical Engineering. So if you actually want to know about coming to that from other degrees, because it has roots in You can find out about it there. So just added that. That's
Yeah,
in the that link.
that's great. Yeah, so obviously I'm the undergraduate submissions tutor, so I'm kind of giving you the view from undergraduates as if you're going to come to us, do the undergraduate degree, and then perhaps go into employment or go elsewhere. But we do have master's programs. We, as Kim said, we've got the MSc program. We've got one specifically in stem cell and regenerative medicine. We've got a master's of research program in synthetic biology. There's lots of options to move on to postgraduate study. And of course, then we have PhDs and ND programs as well. So those are all really good routes. So let me have a look. Would I be able to where was I? Computing. So that's really good. I knew I'd seen that. So talking about those optional modules, one of those optional modules that you can choose would be in, not in computer science, but it would be about coding or about computers delivered by the Department of Computer Science. So we're in the engineering faculty, and the engineering departments in the engineering faculty offer what minor modules, and they are usually then open across the college. So the department, the computer science department will offer minor modules, and our students, depending on which degree they're on and whether it's on their module diet, they can choose to do that minor module. So it's not a CS degree, but it's an introduction to coding, to using software. And there's a really big push within the department to bring that to the forefront, because so much of the new technology, there's a real buzz at the moment around AI, around automation, digitalization, okay, what they call Industry 4.0, that's another buzzword sort of term, which is using AI, using advanced computings, using, language models to help in the process, the design process. So there's a component of that internal to our degrees, but also you can take minor modules from the computer science department at UCL as well. Yeah, so hopefully that answers that one. What is the biggest difference in the job outcomes of biotechnology engineering and biochemical engineering? That's a good question, and I'm not sure it's one I can answer because I'm not familiar with the course offering of biotechnology engineering. When I hear biotechnology, the thing that comes to my mind are sort of things like medical devices. It's more about like built devices, technology, rather than large scale engineering processes. So my feeling, and it is a feeling, so I can't say for sure, is that biotechnology in that respect would lend itself much more to sort of medical devices focused around human anatomy. But I can't really say because I'm not sure what the biotechnology engineering offering is. I'm sorry. Okay. Would I be able to go into the sectors of employment that you talked about, having studied biochemistry? Yeah, absolutely. You could go into GSK, you could go into Eli Lilly, having done biochemistry. What you wouldn't probably be able to do is go into their production side. So, you wouldn't be able to go to the pilot plant floor or the production floor and say, okay, I'm going to run this 10,000 liter reactor. Yeah, you'd much more likely to be in their R&D department. Yeah, and our guys or students will go into the R&D, but they could also go to the manufacturing floor because they've got the engineering, but they've also got the theoretical and the lab bench practical. Yeah, whereas with biochemistry, tends to be much more small scale lab benched early stage research. So for those companies, it's much more likely that you go into the R&D sector. Yeah.
So I just want to.
Yeah, sorry, Kim.
Somebody earlier asked about chemical engineering, biochemical engineering. My understanding is that as a biochemical engineer, you are qualified to work in chemical engineering. You have learned all the same theories. You are fully qualified to go into that sector. However, chemical engineers cannot go and work into the biochemical engineering sector because the way you're taught in biochemical engineering is with biological examples. It doesn't work the other way. So that's one of the things which is a feature of our programs. Is that right, Jack?
Yeah, I think that's a really great way of putting it, because those chemical engineers won't have been taught the biological systems. Yeah. And in lots of ways, those biological systems are a lot more complex. Yeah. Than sort of the chemical engineering system. So absolutely, I think that's a great way to put it, Kim. Right, what have we got here? We did have some questions did they get put in the chat by accident? I don't know if we can bring those across.
There is was when somebody asked one in advance. I think it might. They just asked what tips can you give to high school students who are considering selecting this degree. So so I think beyond the selection of your choices, what things might someone who's doing their IBAC or A level consider doing to help them with apply for this course?
Yeah, apart from selecting, so getting the right degrees, getting the right courses is the big one, and then if it's possible, and it's not a requirement, okay, we don't require it for reasons of equality and access, but if you can get some experience in a related field, if that's some experience at a lab bench or some experience at a company which works in the field, that always helps with the personal statement. Although it's not a requirement, I do stress that. Don't feel like if you don't have that, you won't be able to get in, because it's not a requirement, because we know that that's not accessible for everybody, and so we have to be fair. And the other thing is to just show a general in your, and this is kind of more about your personal statement, because that's how we do entry. Yeah, it's grades and then it's personal statement. So showing some interest in the discipline, showing that you're enthused or engaged with the field or where it might lead. I always say that to students, and it doesn't, you don't have to give us chapter and verse about this one particular thing, but just show that you've got some interest and some understanding of the field, where it's been, where it's going. That's it really. I wouldn't say more than that than you need. And mainly it's about attainment. If you can get those courses, get those grades, yeah, that's 90% of the battle. Yeah. Cool. I think I'll go back to these ones here. So knowing the course is unique to UCL, would you say this course is known and respected by employers outside of the biochemical engineering industry? That's a good question. It's absolutely known and respected within the biochemical engineering industry. There are UCL biochemical engineers everywhere you go, and I mean everywhere you go. And I've been lots of places, and I can always spot them because they were the only sort of place that does that degree. So when they tell me that, and I say, well, I know where you've come from, Ben. When it's outside of that industry, I absolutely think it is respected, but what I would say is it's probably most likely respected because it's a good degree from UCL. Yeah, so if you're not working in the biochemical engineering industry, if you're going into something else, then they may not know about biochemical engineering. They may not know that we're the sort of the only people who do it. They might just be like, okay, great. Lots of people do that. But if it's a good degree from University College London, that carries a weight in itself if you're going outside of the discipline. Yeah. So I think that's probably the best answer for that. Yeah. Okay. Is there a big difference in opportunities for people that do the year in industry versus don't? I don't think there's a big difference in the opportunity. You can understand how it is easier for people to transition into the company if they've been working there for 9 months already. Yeah, because they've effectively already taken on board the processes of that industry, that company, they're known, or they know people in there. But the thing about the way we run the course is that we have a lot of poster presentations. We have a lot of visitors from industry who talk or give lectures, networking sessions, and we have a lot of alumni in these industries who we are in contact with. So even if you don't do that year in industry, you still have the ability to access that network of alumni, which will open doors or provide routes into at least getting your foot in the door or hearing about opportunities or making connections. So obviously doing the year in industry helps in that short instance with that one particular company, but more broadly in the sector, because we have these great links with these industrial collaborators, and because so many of our alumni go to work there as well, then if you come to study with us, you'll have an access to that very broad network, okay? Even if you don't do the year in industry program. Okay. Excellent. I'm just making sure I don't miss anything. Can the year 3 BEng program change to the 4-year MEng? Absolutely, they can. What we suggest to people applying is that if you're unsure whether you want to do the BEng or the MEng, apply to do the MEng. The entry requirements are exactly the same. Apply to do the 4-year, and then on your way, if you want to just come out at 3, it's easier to transition from the 4-year to the 3-year than it is to go to the 3 to the 4. It's not impossible to do it that way. It's just easier to do it 4 to 3. So if you're in any way unsure, apply for the MEng, and then you can just say, actually, I want to step back to the BEng. That's perfectly fine. You can go the other way, but you have to let us know, at least by the end of year 2, that you want to go from the BEng to the MEng. Okay, so there's a bit of a time pressure on it that way around, but it's not impossible. It's absolutely been done before. Yeah, and the entry requirements are exactly the same. They're the same degree, it's just one got an extra year, a master's on the top, effectively. Yeah, perfect. Hopefully that one opens. That one. Can I do a bachelor's in biochem eng and then a master's in finance? Yeah, I don't see why not, as long as you meet the requirements of the master's program. Yeah, and that would be attainment. And it may be that they have some requirements about modules that you might have to done or things like that. So if you want to do that, I just make sure that you identify what the requirements for that master's course is, and then see if you can tailor your learning to that. So finance, maybe something around business, maybe on your BEng, you're like, okay, I'm going to take a minor in business and management or accountancy or commercialization, if those are available, and you add that in. So on your CV, your application, you're like, I've got a first class degree from a great institution, but I've always known that I've been interested in finance and business, and that's why I tailored my learning to try and get some understanding of that while I was on that course, and that's why I think I'll be great for this master's degree. Yeah, something like that.
And also just want to say, do look at we do a BSc as well in bioprocessing new medicines, business and management. So have a look at the content of that, because it might be that that's of more interest to you than the BEng program. So have a good look at the content and what's on that one, just to see what's available there.
Absolutely. And that one, module wise, has lots more modules inbuilt which are about business management, accountancy, commercialization, and things like that. So that may make more logical sense. But have a look at the modules that are on both, as Kim says. That's a really great idea. Okay, all right, what else we got? I hope I'm doing them in the right order. How much of the course is made of these optional modules? Off the top of my head, in the BEng and the MEng, you start your minor course in year 2, and it's a limited number of credits. I can't recall off the top of my head, so I don't want to say, but that is on the website. If you go to the course description, it will tell you. And it's from a diet. So we say you can choose from these minor options. Okay, so we give you a limited list of things you can choose from. From the BSc, it's more credits. I think it's 40 credits. Again, I'm not too sure. The information detailed is on the website. But that you can take modules from across the college. So any department that gives a minor module that people can join on the BSc, you can do that. So the choice of modules on the BSc is wider, and you can do more credits. Yeah. And that's really to do with the accreditation. So the accreditation, we have to hit specific things to make the accreditation. And if we allowed students to just pick any minor module, then that would be very difficult to sort of accredit that. So that's why we give a much smaller module diet for that one. Does ChemEng have more job opportunities than BioChemEng? That's an interesting question. And at the moment, what I can say is that I personally, and from colleagues in the area, we've seen a fall in the number of graduates going into chemical engineering. And I think if you think about what you know from your life, as a society, as a species, we really need to start moving away from fossil fuels. It's hard because they, do a lot of things, but we need to move away from the fossil fuel industry. And it's not just the therapeutic sector. And in the UK, a large part of government expenditure and planning is in advanced therapeutics. So that's a growth sector, but it's also in the sustainable chemicals industry as well, which is a growth sector. And that's kind of competing with fossil fuels. So fossil fuels obviously is still a huge and dominates large parts of the industrial sector because of legacy reasons. But hopefully, and it is a hope, that share will decrease over time due to government pressure, environmental pressure, societal pressure. That we really need that to happen if you think about climate change and sustainability. But what the level of job comparison is at the moment, I don't know. I'm sorry, I can't speak to that. Okay, what level of physics knowledge is needed to do a biochemical engineering degree if I have not taken it at A level? It is not required. So the only thing that we require is maths at A level, okay, or its equivalent, depending on which country you come from. And then you can have biology, and it needs to be A. So 3 A's, all degrees have 3 A's. A maths for B Eng and M Eng, and then I think it's one of the other sciences, so chemistry, physics, or biology, and then the third one is a choice of your own. Okay, so you don't need to have physics. You could have biology, chemistry, or physics as your second A, and then your third A could be one of the sciences. It could be English literature, it could be history. Yeah, that's for the B Eng and the M Eng. So it's really the maths, because that's what you'll need for the thermodynamics, the fluid flow, the chemical engineering side of the degree. Okay. Would it be an advantage if I did EPQ or Lambda enrichment program? It might be if I knew what those were. I'm really sorry, I don't know what those are. So I can't speak to that. I'm really sorry. Personal statement. If the personal statement is for another biological department, could that use of biochemical engineering? Yeah, we're aware, obviously, that we are the only department that does biochemical engineering. So what we say is that in the personal statement, so long as you've got something, I say to students, a line or two which says, if you're doing biochemistry, you could be like, oh, I'm really interested in, the fundamental control mechanisms of DNA because I find them really interesting. And I know that if we study them, we could use them and engineer them to develop and design and deliver drugs. In that way, you're talking about biochemistry, but you're linking it to biochemical engineering. So long as in your personal statement, if you want to make it quite broad, because you want to apply for biochemistry or a different degree which is related but not the same, then I would suggest doing something like that, something which isn't going to stand out in a biochemical. They won't look at that in biochemistry and be like, oh, that's a bit weird. They'll be like, okay, yeah, that makes sense. But also we can see that you've got an interest in application. And I think talking about biochemical engineering, really, biochemical engineering is the application of all of that scientific research knowledge to provide something. Yeah, it's translational from the bench to real world. Yeah. Okay. Personal statement. I think that answers that. What is the advantage of doing a year in industry versus just finishing the degree and applying for jobs after? Good question. So I guess the year in industry advantage is that you've got a link and a route into that industry. So it's a bit more guaranteed, perhaps not complete guarantee, but you can see how that might logically transition. If you come out a year earlier and you go into work, you've got one more year of being in paid employment, right? And another year where you've started and then can progress up the sort of employment structure within the company. So those are the sort of things that you've got to weigh up, really, between those different things. A year of being paid a full wage, or and moving up, or but also you're coming out and you're still going to have to look for those jobs. You're still going to have to network. And we have that network, as I've mentioned before, connecting you to employers. We have a careers advice service as well that we offer to try and help students get into employment. Absolutely. So those are the sort of things that I can think off the top of my head that you'd have to weigh up. Which one out of biochemistry and biochemical engineering would keep my options more open? I'm not sure about what career I want to do. That's a good question. And I don't know. Both of them, if they at UCL, are good degrees from a good university. So that immediately opens doors for you. I did a biochemistry degree and I ended up here. I came through a startup company. So I mentioned Accitan. I actually went out with Kane and we span it out together. I was the CSO there. So I've been in industry. I've come back. But I started off at biochemistry. Yeah, I did a PhD. At this stage, I think neither of them precludes. Biochemistry, as I said, if you were going to go into GSK, that would most likely be in the R&D side. If you did biochemical engineering, you could go in the plant, but you could also go R&D. So that maybe is a bit broader. But probably at this stage, I wouldn't say either of them narrow it down too much. Unless you wanted to I don't know, go into medicine, but then you'd have to do a degree in medicine. So, but of course, you can always, lots of people do graduate conversions to medicine. That's not uncommon either. That can be done, like the graduate law degree conversion. Yeah. Okay, perfect.
I think we've actually managed to get through all the questions. and right at the end of the session.
Perfect timing all the way through.
That's a feat. I mean, I just want to finish up by saying thank you for those questions. They were absolutely brilliant. Really appreciate your enthusiasm for the subject. And I'm actually there's just one final question which has said the presentation had an average salary of 38k. So would there be a figure for starting salary? These figures that we're giving, they're provided to us by HESA, so it's something that we have, so we can't dig into the data any further than that. It's provided in a way that means that you can compare like with like from university to university, which is how we provide that data to you.
Yeah, that was the average, wasn't it? So you'll get a range around that, and it will depend on the industry you go into. Yeah. So whether you go into research, whether you go into project management, whether you go into consultancy,
or you know, if you start on a graduate training scheme, so they're
absolutely.
what I will say is that one point that's worth making is that we actually have a team in UCL Engineering specifically dedicated to careers, and they will continue to support you 3 years after your graduation. So not only will they help you get into work, they're there to help you develop your career afterwards. So and they are still there for you long into your career. So I just want to let you know about that opportunity. They're also very, very active in organising events. Right, we've come to the end of our session. Listen, if there's anything that came, which you burning question, which you didn't get to ask here, we didn't answer fully, I've sent my email address to you, and like I said, I will email you afterwards with a link to this recording, with a link to our Spring to STEM taster sessions coming up. Thank you very much for what you said in the chat. We very much appreciated.
Thank you.
But we're going to say goodbye now. We hope you have a fantastic week, and we do hope that we get to see some of you in person in the future at UCL.
Absolutely. Thank you so much.
Bye-bye.
Bye, everybody. Bye-bye.